All right. Hello, everyone. My name is Corey Kinney, and I'm a vertical marketing manager here at DriSteem. And I'd like to welcome you to our first session today on our humidification webcast series. Today, we're going to be laying the foundation in this conversation about how to get started with humidification, what information you need, how to size your system, and how to make confident design choices. I'm joined today by my colleague, David Baird, application engineer here at DriSteem. David brings many years of experience helping customers design and implement effective humidification systems across a wide range of industries. He's been my go-to resource when it comes to navigating the intersection of engineering, equipment, and application performance. So, David, I really would like to thank you for being here today, and I'm excited to dive into these topics with you.
I'm looking forward to the conversation.
All right, excellent. So when we're thinking about designing, planning a humidification application, what are some of the key pieces of information required before we start the design and planning stage? And why are those important?
Well, you have to understand first and foremost what you're trying to do. Why do you want humidification in the first place? Are you trying to preserve some museum artifacts, as an example? Are you trying to help a process, a clean room? Is it just for comfort? Understanding what your goals are initially will help you go through the process. Once you kind of understand what your goals are, then it's starting to think through, okay, how do I add the moisture? I know I want the moisture because I've defined that based on the process. And it's getting into, okay, where can I put this? Am I going to go into an airstream? Think of it in ductwork or in an air handler. Or am I going to put it directly in the space? Then it's going, okay, what is my moisture that I'm starting with and where am I ending at? Then I can know how much moisture I need to add. We've got to figure that part out before we can even get into equipment. And what utilities are available? What are the type of water sources? What are the type of energy sources available? So it's understanding what your goals are, what you have available in order to be able to execute against it, and what are some of the design parameters to help you figure out the sizing and application of it initially.
Sure. So once I get all of that information, how do I end up then using that to determine my humidification requirement?
Well, once you know, as an example, what your starting moisture content is, and that's often we think of from ventilation. We need that in order to prevent our CO2 levels getting too high. And so that if we're in a cold climate such as Minneapolis, it's going to be cold and dry. And if we bring that in without conditioning it, it's going to actually dry out the space. So we need to add the moisture to it. Okay, you have to know what you're starting with. What is that outdoor air coming in the middle of winter? And you know what your target is. What is that comfortable potentially for people or the process that you're working with, or building materials as an example. Once you know starting and ending, and then you get into what is the volume. We know how much outdoor air is coming in for ventilation. So then we have a volume. We can just do a mass analysis between the moisture difference and figure out that humidification load.
Okay, awesome. Are there any inefficiencies or losses that we need to consider in a humidification system? And what are those?
Well, when we were looking at, okay, the starting and ending point and how much air volume, now we have to consider that's how much we need into the airstream. But we also have the piece of, okay, as you said, inefficiencies. If you're adding steam to a cooler airstream, some of that steam is going to collapse back into condensate or water. Okay, it's naturally what happens. You are potentially making steam and then you're dispersing it. And you have to get from point A to point B if they're not next to each other. If you're going through piping, then how much of that steam is collapsing back into condensate, going from point A to point B as well. So both of those are important pieces. You know how much you want in there, but how much do you have to have at the start so you can achieve what your goal is? And there's different ways that you can mitigate some of that. Insulating piping, you want to keep it as steam. You put the energy into it, let's keep it as steam and not collapse it back into condensate. You can do the same thing within the airstream. Keep the tubes hot so then they're not getting cool, causing that steam to collapse back into condensate. That's one way. Keeping your distances short, so your piping short, and insulating it so that way it can stay hot, it can stay close to steam, and not collapse back into condensate are ways that you can help mitigate that problem.
Sure.
But inefficiencies will happen.
As we start kind of thinking about, hey, we know we need a humidifier within our air handler. How does maybe the choice of energy source influence our selection of a humidifier? And how does that also influence maybe the overall system performance?
Well, and if we go back to understanding our utilities, what type of water sources are available? Do you have well water? Are you working with softened water? Do you have really clean water like reverse osmosis or DI? That will help kind of from a maintenance standpoint of a humidifier. But then you've got, okay, you have to have the steam available, as an example. Do you have a boiler that's already there? And if there is, do I have enough capacity to shed some of that steam out into the space for humidification? If not, then you're going to have to make the steam. And this is where understanding, do I have electricity? If so, what kind of voltage and phase? What specifically is it? Or do I have natural gas?
Mm-hmm.
And now that I've got that, how am I going to deal with the venting? Because a byproduct of that combustion is flue gases. Well, if I'm going to put it on a roof, it's not an issue. If it's in the middle of a building, a little bit different. So those utilities pieces will kind of drive some of that. Traditionally, it's done with steam. And so you either have the steam available or you have to make it. And how can I make it? Because it's going to require energy to cause it to go from water to steam.
How maybe does the intended purpose of humidification affect technology selection? And when might cooling be a factor?
When we think about the application, one of the things that we didn't talk about is how tight of a control do you need? Do you need to have the RH in a very specific range for a process that's critical for that piece of equipment? Or, it's for comfort. We can handle a pretty wide range. There's an ideal range we want to be. How tight a control will kind of influence the product that you're even considering because of what your requirement is. Then it's also thinking through, okay, you mentioned cooling. Well, one of the things we didn't talk about is instead of using steam, you can actually spray water in order to be able to get that humidification. If you spray small little water droplets into the air, it'll make it into the airstream. So you're humidifying. But that phase change has to happen to change it from water droplets into water vapor, which means you end up with a cooling effect of the airstream. It's taking energy out of the air. So it's a different way to think about it, but you're still adding the moisture, but now you're thinking of, instead of me adding steam and creating it initially, I have to take energy out of the airstream for water droplets.
So when we're thinking about placement of a humidification system, how does that placement influence the overall setup of our air handler?
Yep. So if we go back to our example, if there's a boiler, okay, they've already got the boiler. You don't need any extra pieces other than you need to disperse the steam. And so then you think through, where could I apply the steam? And steam doesn't dissipate immediately.
Mm-hmm.
Having it in an even airflow is an important piece. So doing that potentially in an air handler where it's going to distribute to all the different spaces in a building, or if you just want a specific space, then you're into a branched piece of ductwork as an example. Okay, what is my goal again as to where that might be best? But if you don't have the steam available or even water droplets, you'd have to make those. Now you've got additional equipment that you're working through. Going back to that example, if you're trying to do a gas humidifier in the middle of a building, you've got to get the utilities there and then the venting out of the building. Well, if it's in the middle, that may be a challenge. Electricity doesn't have that additional constraint.
Sure.
And so that placement of, well, where can I put it? The other thing to kind of keep in mind is if you put it tucked away in a corner or up in a ceiling, I often think of if it's out of mind, it's not likely to be maintained. So if it's in a mechanical room where you've got a lot of other equipment you're going to service, you're going to know, hey, that thing may need some work. And you can check on it. So you have to kind of think through that portion as well. If you have to make the steam, make it accessible because there will be some maintenance. If you give it really hard water, you're going to have mineral deposits behind. They have to be managed. If you give it clean water, less maintenance, but you still want to check and make sure the thing's operating, other than knowing I'm at the moisture content I want or I'm not.
So you kind of touched there on some of the maintenance concerns. Are there any other maintenance concerns apart from kind of like the mineral buildup? And I guess, how does that influence the selection process? Is that kind of just exactly like you were just saying there?
Well, if we are talking about making steam initially, you've got a steam generator. The harder the water, the more mineral deposits will be left behind because it is the water vapor that leaves and the minerals stay behind. And how you deal with that maintenance, if you've got a large tank, okay, maybe it can collect for quite a bit, but if it collects for some time, it's hard water, it starts to coat the heat exchangers or heating elements, as an example, causing inefficiency. It's not going to be able to transfer into the water, which is what you want to cause that phase change. Okay, do you want to get in there and scrape it? That's no fun. Maybe you want to use some type of cleaning chemicals to try and do it, but you have to make sure that it's safe for the equipment.
Sure.
You could, instead of maybe cleaning it, you could consider a type where maybe you just change out a cylinder. You replace the tank entirely.
Sure.
By doing that, okay, the maintenance just changes. Instead of having to clean it, you simply replace it. And so just maintaining that accessibility is an important piece. And water is one of those key things. If you shift to having cleaner water, you maybe shift the maintenance to the water treatment equipment instead.
Sure.
I can maintain a water softener. I refill it with salt. Then that makes it easier and not as hard on the humidifier. I've just shifted the maintenance and what I have to do.
Sure. Makes sense. What are some of the sanity checks an engineer can use to ensure that the moisture to air ratio is appropriate? And I guess, are there any tools that help simplify that process?
So going back to kind of figuring out how much moisture you need initially. I said you had to understand what you're starting with moisture, what you're ending with moisture, and your air volume. And then you've got to do a mass, convert the CFM example into mass. Well, that sometimes seems complicated. You can look at a psychrometric chart, and if you've ever looked at one, there's a lot of lines. It's very busy.
Sure.
And understanding, okay, which pieces of information I need to get into it. Otherwise, there's tools. Load calc, as an example, is a great tool that can take a number of those pieces of information. I think of it in CFM. I know my starting temperature and relative humidity, and I know what my target is at the end to determine what that is. That is one way that can tell me how much moisture I need to begin with. A sanity check, as you mentioned, there's a general rule of thumb. Those can be helpful to kind of make sure, hey, I'm in the right ballpark.
Sure.
And in general, for comfort applications, 2 to 3 pounds an hour per 100 CFM of outdoor air. And we focus on that outdoor air because the air that's coming back to the space already is at the moisture content. It's conditioned. It's that ventilation that we're bringing in our cold Minnesota winter that is not at the moisture content we want, which is why for humidification purposes, we're focused only on that outdoor air primarily. Sure. And so if we know the amount of outdoor air coming in, divided by 100 times 2 to 3, and that's kind of a range. It depends on climate. And for comfort, a process may be different. But that'll kind of make sure that you're in the right ballpark.
Sure. Excellent. Well, you know what, David? That was actually all of my questions I had here for getting started with humidification. So that's our first session here. I really want to thank you again for really breaking down the fundamentals of humidification system planning. So audience, I thank you for your time today. And I want to make sure that you know to check out our next webcast where we'll be walking through all of the particulars of isothermal dispersion. And just also want to plug, if you are ever interested in looking at how do I calculate my load or any other humidification resources, you can check out all sorts of content like that on our website, DriSteem.com. So thank you again for your time today, and I hope you have a great rest of your day, and I hope to catch you next time.
Now, Corey, you introduced the term isothermal dispersion. Does our audience know what that is?
Come back next time. We'll show you.